Good afternoon, dear students. How are you? I'm fine. Today's class will discuss about uses of alkaline earth metals and some compounds of alkaline earth metals. We have already discussed about the uses of beryllium and magnesium. Today we are going to start from calcium. Calcium is widely using element in our daily life. Let's see the uses of calcium. Mostly calcium is using as a for making the cement and mortar. So the cement and mortar mainly using for construction works. The next use, using as a reducing agent. So calcium is using as reducing agent in the metallurgy of uranium, zirconium and thorium. That means to separating out the uranium, zirconium and thorium from the ore, from their minerals, we use this calcium as a reducing agent. Next use, this is also using as a deoxidizer, desulfurizer and decarbonizer. So we use this calcium as three deoxidant, deoxidizer and desulfurizer and decarbonizer. Desulfurizer and decarbonizer for ferrous and non-ferrous alloys. So the alloys in the ferric alloy or the ferrous alloy, we use some non-ferrous alloy also as a deoxidizer, desulfurizer and decarbonizer. So next one, using this calcium as fertilizers and concrete and plaster of Paris. For the concrete we using this one calcium, and plaster of Paris also the compound of calcium. And using this as getter in the vacuum cleaner, and using this calcium as a dehydrating oils. Okay, so these are the main uses of calcium. Next one, strontium. This is also one of the important alkaline earth metal, and we use this mainly strontium isotope, strontium 90, using this for cancer therapy. Strontium 19, and also using this strontium as finding out the age of rock. That means dating rocks. Okay, to find out the age of rock, we using strontium. Another important use of this strontium is very important. Strontium 87 and strontium 86. These two isotopes are using here this common ratio. This ratio of isotopes are using here to find out the marine investigation. For the marine investigation, we use strontium 87 and strontium 86, and also for teeth investigation and tracking the animal, the migrating animal, to track the migrating animals. and also for criminal forensics. The next one, and this is very important to find out the uh, ages of rock, and also we use this in the archaeological material such as timbers and coin to get the source of this archaeological materials. So these are the uses of strontium. And next compound is barium. So first use of barium is deoxidizer in copper refining. So this is also using as a deoxidizer in copper refining. Okay, so refining copper, the process of refining copper, we use this barium as a deoxidizer. And barium is playing an important role in metallurgy process. In the metallurgy process, using this barium as a pyrotechnics and petroleum mining and radiology. So in this all the department we use this barium. One of the important use of this barium is using as a scavenger. Okay, using as a scavenger. So using as a scavenger to remove the lost traces of oxygen and other gases which is formed in television and other electronic and some other electronic tubes or the electronic materials. Okay, so we are using this barium as a scavenger to remove lost traces of oxygen and other gases. Okay, and other gases. So where using this as a scavenger to remove the we use this as a scavenger in the television and some other electronic tube to remove oxygen and some other gases. Barium isotope, barium 133, this is isotope of barium. So this isotope using as a detector, gamma ray detector, using as gamma ray detector in nuclear chemistry. Okay, in the nuclear chemistry. We use this barium 133 isotope. So these all are the uses of barium. And next one is radium. This is the last element of this alkaline earth metal. You know that generally radium is a self-eliminant element. So you can use this radium to some material. We used radium. It is a self-eliminant element. So that's why if you look at that in a dark place, you can easily see that the self-eliminant character of radium, and even in the light also it can show the self-eliminant character of radium. So using this self-eliminant character, this radium is using as a paint for watches and nuclear panels, aircraft switches and clocks and instrumental dials. So using as a self-luminous paint. Self-luminous paints. nuclear panels, aircraft switches and clocks, as well as instrumental dials. Okay, so these are the uses of alkaline earth metals. Important compounds of calcium. So from the alkaline earth metal, calcium is an widely using element, and that is a important compound. So from that calcium, we are going to see some compounds which is combined with the compound which consists of calcium. Okay, so first important compound of calcium is quicklime. So quicklime is the chemical formula of this quicklime, calcium oxide, CaO. This is general chemical, it is a chemical formula of quicklime. Let's see the preparation of this quicklime. So as like the alkali metals, in the alkali metals we saw some important compounds of sodium. So in the alkaline earth metals we saw some, we are going to see some important compounds of calcium. So first compound is quicklime, and the chemical formula of quicklime is CaO. And now we are going to see the preparation of this quicklime. So we use this preparation of quicklime to heating up the calcium carbonate. So calcium carbonate heating up in the lime kiln, in the temperature range will be 1070 to 1270 Kelvin. Okay, so it is a commercial process to prepare this quicklime with the help of calcium carbonate in the lime kiln in the about the temperature 1070 to 1270 Kelvin. So the range is 1070 to 1270 Kelvin in the lime kiln, and the temperature range we already learned, written here. So how it is separating calcium oxide plus calcium is combined with one oxygen from carbonate. Now it's become CaO, and remaining CO2 is form CO2 gas. You can see we put some symbol here in between this reactant and product. The symbol is indicating it is a reversible process. So when this calcium carbonate is undergo the temperature 1070 to 1270, it is a reversible process. When they produce, if they combine this calcium oxide and carbon dioxide combine, they can produce calcium carbonate. So that's why it's called a reversible process. So when this reaction form carbon dioxide, it's as soon as immediately it is removed from this process, and you can easily get the calcium oxide as a product. The preparation of quicklime is explained in this figure 5.10. So lime and coal mixture, it is put into the lime kiln, and under the temperature it is heating up, and it's given here lime out, that means calcium oxide. It's formed and taking out from this hole, and the formed gas, the CO2 gas, is going by this tube as a gas. Okay. Next, properties of calcium oxide are quicklime. So calcium oxide is a white amorphous solid white in color, and amorphous solid. Their melting point 2870 Kelvin melting point. When expose this quicklime into the atmosphere or into the air, they can absorb the moisture and carbon dioxide. So when calcium oxide is exposed into the air, they absorb moisture and carbon dioxide, and the reaction between the calcium oxide with carbon dioxide and moisture, that means water, calcium oxide combined with moisture, that means water from the atmosphere, they can produce CaOH twice. So calcium hydroxide. Then calcium oxide, again it is exposed into the air and they absorb carbon dioxide, or they react with the carbon dioxide, and they can show the resultant is calcium oxide combined with the carbon dioxide. So this O is combined with the CO2 molecule, they will become CaCO3, that means calcium carbonate. Next property, when quicklime is reacted with a limited amount of water, they breaks the lumps in the calcium oxide. So they breaks the lumps of this lime, or so this reaction, this breaking of lumps in the lime reaction is generally known as slaking of lime. So the process is generally known as slaking of lime. So this slaking of lime product is known as slaked lime. So this process is known as slaking of lime, and the product of this reaction, this slaking of lime reaction, we got some product, we are going to get some product. That product name is slaked lime. So when you treat this quicklime with a specific amount of water, they breaks lumps of this lime, and this breaking lumps of lime is generally known as slaking of lime. That process generally known as slaking of lime, and because of this slaking of lime, we got some product, that is slaked lime. So what is the product of this slaked lime? This process is known as slaking of lime. Why it is called slaking of lime? This quicklime is combined with some amount of, or the specific amount of water. So because of that, they form calcium hydroxide. So this product is known as slaked lime. So this is known as slaked lime. Next property, when this quicklime is react with the soda, they produce solid soda lime. And this is combined with they can combine with some oxides like SiO2 and P4O10, and they produce, or they formed here, the calcium CaSiO3 and also Ca3PO4 twice. Okay, so these are the product. So when the calcium oxide or the solid calcium oxide combined with the acidic compound like SiO2 and P4O10, the product will be CaSiO3, then Ca3 PO4 P 4 times O PO4 twice. Okay, we use this calcium oxide to manufacture the or to prepare the cement and mortar and also glasses. Okay, the next use, we can use this calcium oxide to manufacture sodium carbonate and slaked lime. Sodium for the preparation of sodium carbonate and slaked lime, and also using this calcium oxide as a purification of water in the process of purifying sugar. Okay, purification of sugar. Okay, sugar. The next use, also using as a drying agent. Next important compound of calcium is calcium hydroxide. So what is the formula of calcium hydroxide? CaOH twice. How to prepare this calcium hydroxide? When treating this calcium oxide with the water, calcium oxide with water produce calcium hydroxide, CaOH twice. Then the properties of calcium hydroxide. This is white color powder one. It's not like the previous one, that is white color amorphous solid, but this is white powder. White powder, and this one is sparingly soluble in water. Sparingly soluble in water. So aqueous solution of, or the mixing this calcium hydroxide with water, that's known as lime water. So this lime water, so what is lime water? Aqueous solution of calcium hydroxide. So aqueous solution of calcium hydroxide is known as lime water. So the suspension which is in the slaked lime process, that water is known as milk of lime. So the suspension of slaked lime in water. This is known as milk of lime. Don't confuse these two. Aqueous solution of calcium hydroxide is different, that is called lime water, and the slaked lime, that the suspension in the slaked lime in the water is known as milk of lime. When treating this lime water with carbon dioxide, so lime water means, what is lime water? Aqueous solution of calcium hydroxide treating with carbon dioxide or passing carbon dioxide through this lime water. This lime water will turn the color milky in color. Okay, so why it is formed the milky in color solution? Because of the product of calcium carbonate. Okay, so the lime water, what is lime water? Aqueous solution of calcium hydroxide. So calcium hydroxide is mixed with water, so that is lime water. It is treating with carbon dioxide. So this carbon dioxide is passing through this lime water, and this carbon dioxide turned this lime water into milky color. That means because of the formation of calcium carbonate. Calcium is combined with the CO2 and 1O. So this becomes CaCO3 and the remaining H2 is present, 1O is present. So it forms H2O. So the continuation of this reaction, passing this again passing some more amount of carbon dioxide to that solution, this precipitate is dissolved and they form calcium hydrogen carbonate. So the reaction for forming calcium hydrogen carbonate is calcium carbonate. That means this solution, okay, that solution also reacting with excess amount of carbon dioxide. The solution contains calcium carbonate and water. So calcium carbonate plus water is treating with carbon dioxide, and because of this reaction it forms calcium hydrogen carbonate. So this is the reaction to form calcium hydrogen carbonate. Next property, milk of lime is react with chlorine and they form hypochlorite. So hypochlorite, using this hypochlorite as a bleaching powder for the water, bleaching water, and using as a bleaching powder. So the formation of this hypochlorite is 2CaOH twice combined with Cl2, they form CaCl2 and CaOCl2. CaOCl twice plus 2 molecules of H2O. So this is hypochlorite. So using this as a bleaching reagent. And we have some uses of this calcium hydroxide. Generally calcium hydroxide is using as a whitewash during the we use this calcium hydroxide in the whitewash for the disinfectant for their nature of disinfectant nature. So we use this calcium hydroxide as a in a whitewash, and also using this is for whitewash, and this is taking part of preparation of mortar and building material. And also using this calcium hydroxide to prepare the glass and turning industries, and for preparing the bleaching powder, and in the process of purifying sugar or purification of sugar. So these all are the uses of this calcium hydroxide. So today's class over. Thank you, students.